All right, grade 11. In this video, we're going to talk about uncertainties in calculations. In the last one, we talked about how to recognize uncertainties and the importance of using them in your calculations. In this video, we're really going to be figuring out how to actually incorporate those values into your final calculations. How do we use each uncertainty and then find the total uncertainty of a calculation? That's the biggest thing that we need to know how to do throughout the course, and particularly in lab reports. So the objective today is that you have to be able to identify absolute uncertainty, okay, of each measurement, and you need to be able to propagate it, which means using them in calculations. All right, so those are the things that we're going to do. And the reason we do that is because, like physicists say, they don't trust you. We want to make sure that every value we look at that somebody reports, we understand the total uncertainty associated with it. If somebody gives me a value and it has 80% uncertainty associated with it, I likely will not trust that the science is going to be valid or not. So in media right now, we are bombarded with numbers, and you know why, okay? Lots and lots of numbers, but they never report the uncertainties. So it's really easy to get scared or get frustrated or start to believe that this cures that and that cures that. Physicists need to see the measurements, and then we can make judgments. So that's an important school of thought. Okay, so the main keywords we're going to look at that you need to stop and make sure that you've gone to your book and gone through, that you know the difference between absolute uncertainty, fractional uncertainty, percent uncertainty, and the term propagation uncertainty. We're going to go through all of that in this video. Okay, so here's an example that we're going to go through first. I'm measuring the length of a lock using a regular ruler that we have in the classroom. That's a millimeter marking ruler. Okay, and we're going to try to make that measurement and find, first of all, what the absolute uncertainty of that measurement is. So if I look at this ruler, it looks to me like that's about 9.2 centimeters. I'm going to write that down, 9.2 centimeters. Okay, but what's the plus minus? What's my uncertainty? What's my confidence in that value? Okay, I have to be able to understand the rules of measurements, which is what we did in our last video. What are the rules that we looked at to be able to say what the plus minus is going to be in this ruler? Okay, so for absolute uncertainty, usually when we're looking at an analog device like this one, we can say that the uncertainty is usually half the smallest unit of measurement, okay? On the other hand, we also have to be rational about it. We can't just go and say this is half a millimeter uncertainty. We have to say, how do we get that measurement, okay? So I know that on this side, I'm going to change the color here. On this side, I have plus or minus 0.5 centimeters. Oops, not 0.5. You see what I did there? Half a millimeter, so 0.05 centimeters, which is half a millimeter. And on this side, I also have an uncertainty of plus or minus 0.05, right? Because I'm making two measurements. I'm measuring this side and I'm measuring this side. Am I really aligned on that millimeter marking? Am I really aligned here on that millimeter marking? Good question. So I would say I have that absolute uncertainty, 0.05 centimeters on this side and 0.05 centimeters on this side. So I would add those uncertainties together to say that my total uncertainty, my absolute uncertainty, is 0.1 centimeters. So the measurement here is going to be 9.2 centimeters plus or minus 0.1 centimeters. And what that means is that the true measurement of that lock can be anywhere from 9.1 centimeters to 9.3 centimeters. So I would tell the world that that lock is within that range. That's what that number means. And this is what's called absolute uncertainty. Okay? We are telling the world that we have confidence that that lock will fall anywhere in that range. Okay, that's an important thing. So that's a new thing that we're presenting in this video for you guys compared to last year, is we're making measurements, but we're also saying how confident we are in those measurements. Okay, so what happens when we're going to be adding and subtracting measurements? Okay, if I'm going to be adding lengths, okay, for example here, if I have 3 cars that are stacked up and I want to add their lengths together and I want to find what is the total length so that I can ship them from United States to Ghana. All right, I need to record that total length. what you need to do is you always add absolute uncertainties for each measurement when you're adding and subtracting. There are rules for what we do when we're adding, when we're multiplying, and all these things, but when we're adding and subtracting, you add the absolute uncertainties. So for example, what is the total length of 3 cars aligned bumper to bumper, as shown in the diagram, if each car has a length of 4.2 plus or minus 0.1 meters? Okay, so my absolute uncertainty for each car is 0.1 meters. So the rule is I have to add 0.1 meters together, okay, for each car to get the total uncertainty, and then I can figure this out. So for the total length is equal to 4.2 meters plus 4.2 meters plus 4.2 meters, which is going to be equal to 12.6 meters in total. And then the total absolute, okay, uncertainty, I just have to add up this number. Okay, it's going to be plus or minus 0.1 meters plus 0.1 meters plus 0.1 meters is going to be equal to 0.3 meters. So then I would say that the total uncertainty, I'm going to put that in yellow, the total measurement is 12.6 plus or minus 0.3 meters. Okay, that's my final answer. So the final absolute uncertainty is 0.3 meters, and the total measurement is 12.6. So again, when you're adding and subtracting measurements, you always add the absolute uncertainties, and that would give me my final absolute uncertainty. And then I just do the regular addition like we normally would when we're adding the lengths of the cars together. So 12.6 plus or minus 0.3 meters. Notice that I put the unit at the end here. I don't put it here, I put it all at the end. Okay, so that means that this length is going to be 12.3 to 12.9 meters in total. Okay, that's quite a large uncertainty. Okay, another thing that you'll see is we report uncertainties in the form of percent uncertainty. What is the percentage of uncertainty in a measurement? Well, the percentage uncertainty is the ratio of absolute uncertainty, that thing, divided by the actual value of measurement, that thing. Okay, so for example 1, what is the percentage uncertainty for the total length of the 3 cars in the previous question? Well, according to the rules that we have here, let's use green for fun. According to the rules that we have here, I would have to take my absolute uncertainty and divide it by the total measurement. Okay, so my absolute uncertainty is going to be 0.3 meters, okay, as we show here, 0.3 meters, divided by 12.6, okay, and that's going to give me a decimal that I would then multiply by 100% like we did in math class to get the final percentage uncertainty. So in that case, 0.3 divided by 12.6, let's quickly do this on a calculator. Okay, so 0.3 divided by 12.6 times 100 gives me 2.4%. All right, so that's the percentage, the total percentage uncertainty for that question. Now, question number 2, find the percentage uncertainty in the quantity Q is equal to A minus B, that's an expression, where A is 587.3 plus or minus 0.3 meters, and B is 573.3 plus or minus 0.5 meters. Okay, so first I have to subtract these values and then take a look at the total uncertainty to find the percentage uncertainty in the quantity. Okay, so I got to go back and remember the rules for addition. When you're adding or subtracting, you always have to add the absolute uncertainties to get the total uncertainty in measurement. Okay, so if I took 587.3 minus 573.3, that's going to give me 14.0 meters as my calculated value. And then if I want to do the uncertainty part, the absolute uncertainty, my absolute uncertainty, which I'm looking for here, is going to be 0.3, and I have to add 0.5, which is going to be 0.8. Okay, so my absolute uncertainty is 0.8, and this is 14 meters. I'm just going to erase this, and then I would put that over here. So my final calculated value is 14.0 plus or minus 0.8 meters. Now, is that what the question is asking? No, the question is asking what is the percentage? What is that in terms of percentage? So then I would have to then go do 0.8 meters divided by 14.0 meters times 100% is going to give me my percent uncertainty. Okay, so if I do that on my calculator, all right, 0.8 divided by 14 times 100 gives me 5.7%. Okay, so my percentage uncertainty for that measurement is 5.7%. 14 plus or minus 5.7%. Okay, that's just another way I could write it if I wanted to. 14.0 plus or minus 5.7%. Okay, that would be the range. Okay, so my value would be 5.7% lower and 5.7% higher. Okay, that would be the range that I'd be looking at for those measurements. Okay, so what happens when we multiply uncertainties? If I'm doing a function where I got multiplication, in that case, you always add percent uncertainties. Okay, so I always add the percent uncertainties for each measurement. And then I use that total percentage of uncertainty to calculate everything else. Okay, so once I get that total percentage uncertainty, then I can calculate the total uncertainty in my measurements. Okay, so here we're looking at calculate the area of a square shown below using these measurements. Okay, so you drew a square and you measured 1 meter plus or minus 0.1 meters and 1 meter plus or minus 0.2 meters. What would the area be? Well, the area is going to be, so the area is equal to 1 meter times 1 meter, which is going to be equal to 1.0 meters squared in terms of sig figs. And then the uncertainty, okay, I need to calculate the percentage of that measurement, and I add it to the percentage of that measurement to get the total percent, and then using that, I can then calculate plus or minus whatever I'm looking for in terms of absolute uncertainty. Okay, so let's find the percentage. So the percentage is going to be 0.1 meter divided by 1 meter times 100%. I'm just going to erase this because there's not enough room. Okay, so if I go back here, my uncertainty is going to be 0.1 meter divided by 1.0 meter times 100% plus 0.2 meters divided by 1.0 meter times 100%. Okay, and that's going to give me my total percent uncertainty. Let's just erase this part here. Okay, so if I would have done that calculation out, I would have found out that this is 10%, this is 20%. Whoa, okay, I have a total of 30% uncertainty. Okay, so then I would take 30% and multiply it by my absolute value. What's 30% of 1 meter squared? That's going to be 0.3. So I would report it as 1.0 plus or minus 0.3 meters squared. Okay, that would be my final value here, because 30% of 1, 0.3 times 1, it gives me my final absolute value there. Okay, now for example 2, this is something that you're actually going to be doing as a little mini lab in class on Friday. Calculate the density of an object, including the associated uncertainty using the measurements below. We're going to be doing a lot of like practical calculations there, so you're going to have to try to figure this out. Okay, let's say that I have a block. I have a block that's 1,000 kilograms, and I forgot to write that 1,000 kilograms has an uncertainty of 1 kilogram. So it's 1,000 kilograms plus or minus 1 kilogram. Okay, and then I have the width, the length, the height. Okay, 1 meter width plus or minus 0.1 meters. The length is 1.0 meters plus or minus 0.1 meters. And the height is 2 plus or minus 0.1 meters. How would I calculate density? So density is equal to mass divided by volume, if you remember from last year. So in that case, it would be 1,000 plus or minus 1 kilograms divided by, the volume, which is going to be length times width times height. So it'd be 1.0 plus or minus times 1.0 plus or minus times 2.0 plus or minus. Okay, now that's the entire expression. So if I want to do the final calculation, the first thing I'm going to do is I'm going to calculate the density just using the measurements without the uncertainties. So 1,000, 1, 1, and 2. That'll give me my total density. Okay, so then density is equal to 1,000 kilograms divided by 1 times 2. Okay, so that's going to give me 500 kilograms meters cubed. That's the density. So 1,000 divided by 2 meters cubed is going to give me the density. Okay, then if I want to find the uncertainty, okay, then what I need to do is I need to find the percentage mass, okay, plus, because remember you have to add all, even if you're dividing, you're adding, when you're dividing and multiplying, you're always adding the percentages. So I'd have to find the percent uncertainty for that value, the percent uncertainty for that value, and the percent uncertainty for that value. So what I'm trying to do is I'm finding the percent of the mass plus the percent of the width plus the percent of the length plus the percent of the height. Okay, so the percent of the mass is going to be 1 kilogram divided by 1,000 times 100%, okay? Plus, the next one is 0.1 divided by 1 times 100. The next one is 0.1 divided by 1.1, or 1.0 times 100. And the next one is 0.1 divided by 2.0 times 100. Whoa, that was wild. Okay, so what does this turn out to be? All right, so what this is going to turn out to be is 0.1% plus 10% plus 10% plus 5% if I did that calculation. All right, so my total percent uncertainty is going to be equal to 25.1%. Okay, so what I would have is I would have a density of 500 kilograms meters cubed plus or minus 25.1%. And if I want to report the actual value, I would have to take 25.1% times 500. So what would that be? So you multiply 500 by 0.251. Okay, so 500 times 0.251. Okay, I would have 500 Okay, now remember you don't write the units here, you'd write it at the end. Okay, and then now an important rule is your uncertainty can only be 1 sig fig. Here I have 4 sig figs, so I got to boil it down to 1 sig fig. So what this would be reported as finally, it would be 5 times 10 to the 2 plus or minus 1 times 10 to the 2. Okay, and these are rules that we will practice as we go throughout. So make sure that you have this video and you go back through it to look at the calculations. What we did in this video was multiplication rules for uncertainty, addition rules for uncertainty, and how to calculate percent uncertainty, and how to calculate absolute uncertainty. And I'm going to leave you with understanding what would you do if you're looking for exponents. Exponents are just multiplication, except you're multiplying the number by itself. So in reality, it's the same rules as multiplication. I'm going to leave you to research that one on your own because the rules have all been presented here. So for example, if I had a measurement like x cubed, and x is equal to 1.0 meters plus or minus 0.1 meters, what would you do? Okay, I know that the final answer is 1.0 meters cubed, but how would I find that final uncertainty using this value? Okay, it's this value multiplied by itself 3 times. So what are we going to put over here? Take some time, do some research. All the rules have been written for you here, and you should be able to rationalize a quick and easy way of doing that for exponents. And that's it. That's all we have for uncertainties. Don't worry, it takes practice, but you're going to be doing it all the time in every lab report.